Ooh, time to start. Oh, what's going on? Oh, it's not there. Oh, it's one of those mirages. Yes, of course, it's down there. Start down there. This is, I think, one of the all-time optical favourites from the whole collection, the Mirage. Beautiful bit of product. Nowadays, sometimes they usually have pigs in them, I think it is. If you put the pig a little bit eccentric like that, and then move it round, you get this extraordinary optical effect as you turn it round, that the pig gets very small and then very large, and very small and very large as you turn it. If it's right in the very centre, the sweet spot, it won't do that. It'll stay roughly the same size, but it's quite fun to play with it and produce that effect there, very large and very small. And then I found several other things were put in the middle, such as dice was a popular one, which didn't do that much for me. I mean, they look okay, but I thought, hang on, what about something which actually moves? If I don't touch this, it doesn't move, that doesn't move. So can you have something that moves? So I tried one of these lovely quivering birds, but unfortunately it's too tall. It's very critical, the amount of height you can have before it goes out of frame. So with a bit of research, I found that a little ladybug, if I took the little magnet off the base and replaced it with a very slim bit of plastic as a base, that works much better. And that's just about the right height for it to appear not just as a mirage, but as a moving mirage. Because when I quiver the mirror, the little legs and head move due to the articulation effect. Very nice. So a moving optical effect. Very, very sweet. They make them in very large sizes and very small sizes. The smallest I've ever come across is this one here, which is totally bizarre. It's a Pokemon, and it's got the two halves of the hemisphere of the parabolas, and inside you can just about make a little creature inside, and it's right at in the bottom there. They also make a very, very large one we've had occasionally, which is about some 2 feet across. That's an amazing thing to look at. Incidentally, the very first versions that came out of these were made of glass. A friend of mine still got at least half of one, but the guy who invented them in California then found it was too expensive, so he dropped it and made it in plastic, it's got first surface mirrors on it. Another effect I discovered is when you put it against your face, you can see all the details of your face close to, but when you put it like this, I'm getting what feels like it's close to a hot surface. It's very strange. What's happening, of course, is the amount of heat coming out of my skin is focused into one particular point. And that's really quite a very strong effect to show how much heat energy is coming out of the skin of an ordinary average person's face. And oh yes, I can hear you very clearly over there too. You can use that as well. So there's a lot of play value and a lot of remarkable effects that you can do with the Mirage. I think it's one of my all-time favourite optical illusions. And still sticking to curved mirrors which are parabolas, as a parabolas. Here's one which I picked up many, many years ago, and it's just a ball that bounces out back and forward, swings back and forward, and it keeps going out of focus. When it's right in the sweet spot, it appears to be huge, and the redness fills the whole of the screen, which is extraordinary. It doesn't work that well because it's a bit rough, but here's a much better one, which I picked up many years later. And when you switch it on, and make it rock back and forward like that, and now it pulsates, and oh, it's a bit like a headache actually. That redness suddenly fills the entire parabolic arch. My goodness, what a sight this is. Beautiful. Just batteries inside to make it work better. So parabolic mirrors have a lot of fun, particularly I think those two. Another form of anamorphism done with curved mirrors, of course, is the cylindrical ones. This is the very first one I ever got. This is a picture which doesn't look like anything in the video, back to modern art, but actually it's a picture there which has been distorted in a regular form to form, well, you need to put a cylinder on it to make it appear. It's a sailing ship. When you look inside, it's actually supposed to be a little placemat, this, but it's only visible when you put on a cylindrical mirror, and then it appears to be a sailing ship. Nice one, and it's symmetrical, both sides, both appear. And that's another version of a cylindrical mirror. And two other versions of cylindrical mirrors which are not at all common. One is a cup and saucer. Here's the picture, but highly distorted, and you can't see what it really is. When you put on a cup, which is all silvered, and place it, oh, there's a famous iconic picture, I think it is, of Marilyn Monroe standing over a grill where there was an updraft. The wretched reporters had played a trick on her. It flared up and showed her shapely legs. Beautiful bit of anamorphic art. Yet another version of anamorphic art is a deck of cards, would you believe? Every one of these playing cards has been highly distorted, and only when you put the little mirror cylinder on it will they appear. There's the Queen of something or other. Queen of Hearts, I think it is. And here's the Seven of Diamonds. Very nicely done. But to play with them as playing cards, I don't know as much. Oh, look, even on the back of the cards you can have something. I think there's even on the back of the cards they have an anamorphic picture. That's nice, isn't it? So it's an entire playing card deck, all of which have this cylindrical anamorphic picture. The last one of the cylinders, which I think is my favourite, is the work of István Orosz. He's a wonderful Hungarian. I've met him twice now. Artisan. He makes extraordinary fine penmanship. He's got it looks like an ordinary picture. It's reasonable. This is actually an anamorphic picture of needing a cylindrical cylinder. But when you look at it, it doesn't look like that at all. It looks like a regular picture. It's supposed to be a scene from the Jules Verne novel, the famous French science fiction writer. There's people here, there's glaciers in the background, there's a curious wrecked ship in the background. And on the sun here, well, that's actually where you put your little cylindrical mirror. So here's a small one I've made. When you do that and pan down, blow me if Jules Verne himself, the author himself, appears in the mirror. That's wonderful. Superb bit of disguised anamorphism, looking like a regular picture, but actually it's a beautifully constructed work of art by this fine calligrapher. I did find other pictures over here and elsewhere when I was looking very carefully. Perhaps my imagination is a bit too high, but I'm sure I saw strange dog-shaped, jackal-shaped things over here and somewhere else. But the main picture is that one there. I think that's a wonderful effect. Now there's another form of anamorphic art which I think is this is a unique one. I've never seen this done anywhere else. We've now shown conical anamorphics and cylindrical anamorphics. This one here is hemispherical because the picture itself, again, looks very distorted. It's a strange one. It's going to zoom up from here to here, and you can't make much sense of it. And you're going to make sense by putting it on, by looking at it on a hemispherical surface. So the top of this tube, that's a hemisphere. It's not a cone, and it's not a side of a cylinder or a parabola, and the picture itself appears inside here. So we'll illuminate it to give it a bit of a chance. It's called a zoom scope, designed by a Japanese artisan about 20 years ago, I think it was, and he calls it a zoom scope. Let's have a go at see if we can make sense of that picture we're looking at. As I move up slowly up the tube, we see a group of people. Then it focuses on a pianist, a lady pianist in the background. Let's move the light up a bit. And we keep moving up, and it zooms in on the lady herself, who's at the piano, then on her face, and then to her eye, and into the eye you go, and there's the universe, well, the stars, and then finally you actually see your own eye and at the front. Let's zoom out again. Come out, and I'll move the light down. It's a wonderful little, like a storyline, but done with hemispherical anamorphics, which I think is the only one that's ever been produced, all the way down to the bottom. Let's come in one more time. Very strange idea. Kjura Yahagi, he's the guy who invented this. Sometime about 30 years ago, I would think. Let's move the light up a bit. The lady's face, the lady's eye, and then the stars, and your own eye appears at the very top. Wow, that's something else. Yeah. And the last item to show is a regular curved mirror, which of course can be used for many other things than just looking at things. It's like a giant bathroom mirror. It has to have a slight curvature, and I find it actually a very good way of making spinning tops perform. That's a tippy top which will perform nicely on a surface. What I like about these ones, if you can get them to perform properly, is when the things spin, sometimes when they're like that, you see the reflection on the bottom, and it looks perfect because you've got two things to look at there. But this is actually the mirror, as you probably guessed from the opening shot, of the famous Euler's disc. And a curved surface is essential for it, but not for the optics. Set it spinning, and it stays in the center all the time and goes on for a long time, a very long time. Wow!